Hello friends, my name is Akash from Civil Engineering Department. So today we are going to learn about theory of pure bending. Now what is pure bending? Many students have this confusion like what is pure bending? They might have studied about shear force and bending moment. But what is a pure bending? That's the question. See, pure bending means when on a beam a load is applied throughout the section, a same amount of load if applied throughout the section, that kind of beam will undergo pure bending. See here on this beam we have shown that it is how will behave before bending. That is, a beam is shown, the moments it will undergo, that is clockwise and anti-clockwise moments. So this is how a normal beam looks before the bending process. Now we come to bending, like how a beam looks after bending. After bending, if you see, these portions have undergone displacement. You can see that the whole beam has undergone a curve effect. So the earlier figure, which had A and C, B and D as its reference point, have now turned into A dash, C dash, B dash, D dash. If you observe, this neutral axis, that is R S, has now become R dash, S dash. That is, the neutral axis has also undergone a curve effect due to bending. Now, if you see that the portion above the neutral axis, this portion, that is the portion above the neutral axis, it has undergone a compression. That means the points have come closer compared to the beam before bending. So that means that portion above the neutral axis is under compressive effect or compressive stress. Now if you see the portion below the neutral axis, it has gone under tension effect. That is, the forces developed behind the neutral axis, that is, it has undergone tensile force. So if you see that above the neutral axis it has gone under compression, and below the neutral axis it has gone under tension. So compression and tension, these alternate stresses will develop a stuff that is known as moment of resistance. That is, the external moment on this beam will try to conflict with the internal stresses that are compressive stress and tensile stress. So both these stresses will form a couple that is equal and opposite. That is, equal amount of compression has been there above the neutral axis and equal amount of tension is there below the neutral axis. So if you combine both these, it has a effect of couple. That is, internally there is a couple developed, and external bending moment will try to inflict its influence on this particular section. So there will be a term that is known as moment of resistance. That is, moment of resistance will be developed by this beam. Now you might have seen what are stress distribution diagrams, right? So stress distribution diagrams are calculated or drawn after having a beam which has gone under bending. So if you see, this is a normal stress distribution diagram where we have shown that the axis, where the axis, that is this neutral axis and the portion above the neutral axis, that has gone under compression, and portion below the neutral axis has gone under tension. So for a beam to resist the load, it should be under these stress boundaries. That is, these are the stress boundaries which will have an effect on the whole beam. If the load exceeds this compressible limit and this tensile limit, then there are chances of collapse, right? So beam will break, and what will happen? The bars, that is the reinforcement bars, will appear on its lateral side. That is, if you see, you might have seen in many buildings which are very old, the beams which have gone maximum bending, there appears a rustic corroded reinforcement bars, right? So that is due to this effect, that is beam has undergone bending process and the reinforcement bars have started appearing, right? So that is a very bad condition which may be calculated earlier. So this is compressible stress and this is tensile stress. So Fc and Ft are the two stresses which are there in a bending, which is pure bending. So what is Fc? It is compression stress. And what is Ft? Ft is tensile stress. But these both the stresses are due to bending. So that is compression stress and tensile stress are both together known as bending stress. So this is all about stress distribution diagram and what is theory of pure bending. Theory of pure bending, that is after bending, before bending, how a beam appears before bending and how a beam appears after bending. So in the next part we will study how a flexure equation is derived, how the equation can be derived for a pure bending. So that equation, we'll just write the equation, that is m by I is equal to F by Y is equal to E by R, where m is moment of resistance, I is moment of inertia, F is your bending stress, Y is the distance from extreme fiber, E is, that is modulus of elasticity, and what is R? R is radius of curvature. Clear? So this equation we will derive in our next part. Thank you.